Hi everyone, in this video we're going to be talking about the distance formula. So this is lesson 1.3 part B, distance formula. This formula is super important for geometry, so make sure you pay attention, take good notes. All right, so what is the distance formula? Well, first of all, distance means the length between any segment. Now, you could say, well, couldn't I just count? But think about if you have a slanted segment. So let's draw an x and y axis here. Let's say we have a point here, call it x1, y1, and then you have a point over here, x2, comma, y2, and you put a segment between them. So the problem with counting here is that each count has a horizontal component and a vertical component. So you would have to account for that, no pun intended. So in order to do that, one thing we can think about, and I alluded to this in our last example, is drawing in a right triangle. So I'm going to take a right triangle here using this length, the actual segment, as our hypotenuse. And we know that a right triangle has a right angle, has two legs, and a hypotenuse. So the horizontal and the vertical component of this line segment would represent the legs of the right triangle. Okay, now in order to find the distance here, with a right triangle, you can use the Pythagorean theorem. Hopefully you remember the Pythagorean theorem from algebra and pre-algebra. It's a squared plus b squared equals c squared. Or I'm going to take a different step here and I'm going to say c is the hypotenuse. So hypotenuse squared. And since the hypotenuse is the distance that we're looking for the distance of the hypotenuse, I'm going to change the h to a d. Okay, and let's dive a little bit more into what a and b actually are. So a is the length of the horizontal component. To get the length of the horizontal component, the horizontal part is the x. So you would subtract the two x coordinates. So the length of a is x2 minus x1. That's how you get a length. And then likewise, the length of b, the vertical component, would be the y subtracted from each other. So y2 minus y1. Now to discover the distance formula, we take the Pythagorean theorem and we use the coordinates that I just marked here. So instead of a, we're going to use x2 minus x1. Put it in parentheses though, because the whole thing is being squared. And then plus b, which is y2 minus y1 squared. And then that is equal to d squared. Well, what if you wanted to actually solve for d? What if you wanted to get d by itself? Well, d is being squared, so the opposite of squaring something is square rooting something. So to get d by itself, you would take the square root of both sides. So then the final equation for the distance formula looks like this. D equals the distance between any 2 points is equal to the square root. Make sure you draw a big square root of x2 minus x1 squared plus y2 minus y1 squared. A few things to note about this formula is that it does matter which x you put first. So if you put x2 first, you have to put y2 first. If you put x1 first, you have to put y1 first over here. So I take that back. It doesn't matter which one you put first, but you just have to be consistent in both sets of the parentheses. One thing you want to make sure to do is do not forget to square and put parentheses around the x2 minus x1, and then square it when you're doing this in your calculator. Okay, I'm going to pull up my calculator real quick. Just so, because it takes a minute to load for when we do an actual example. And then one thing that some people like to do is think of a way they can remember this formula by thinking of it as a face. So if you wanted to think of the distance formula as a face, the square root would represent the hair. The parentheses would represent the eyes, where the subtraction signs represent the pupil. The square on both represent the eyelashes. And finally, the plus sign represents the nose. So if you want to think about it that way, you can. I also posted a picture of all of this in the HyperDoc for today's lesson, if you want to copy that one down, if you just want to take a look at it in a different way. Okay, so let's get to some examples. So it says if A is x1, y1, and B is x2, y2 are the points on a coordinate plane, then the distance between A and B is found using the formula. Okay, you already wrote that down. So let's use this picture here as an example. So find the approximate length. We're actually going to do some practice on finding the exact length. Find the exact, let's do exact and approximate length of JK. So JK, the length of JK is equal to, and this is how I would do this. I would do a big square root. And I would do x2, we'll call this kx, we'll call k the second point, j the first point. So 1 minus -2, close parentheses, squared, plus y2 minus y1, so 3 minus 4. 3 minus 4 squared. So the exact version of this is without decimals and just in square root form. So we can't just type this into our calculator to get an answer. Well, we might be able to, but let's simplify first to see if we can. So order of operations, first you do the parentheses. Please excuse my dear Aunt Sally, and then you would do exponents. So here, 1 minus -2 becomes 1 plus 2, so that would be 3, and then 3 squared is 9. 3 minus 4 is -1. -1 squared is +1, because anytime you square a negative number in parentheses, it becomes positive. Okay, and this would be the square root of 10. Now, to check if this is simplified, you need to ask yourself, are there any factors of 10 that are perfect squares? Well, perfect squares are 4, 9, 16, 25, 36, 49, etc. So the only factors of 10 are 2 and 5. So neither of 2 or 5 are perfect squares. So this is actually in simplified form. Okay, so that would be the exact answer without having to round. If you want to find an approximate answer, say to the nearest 100th place, you would take your calculator and do the square root of 10. That would give you 3.16. So 3.16 would be the approximate answer. All right. How about the midpoint of JK? How would we find the midpoint? Well, remember for the midpoint, do you remember the cheer? It's midpoint. What do? Add the x's together. So 1 plus -2, and divide by 2. And then add the y's together and divide by 2. So 3 plus 4 over 2. And then simplify. 1 plus -2 is -1, so that'd be -1/2. And then this would be 7/2, or 3.5. So -1/2, and then 1, 2, 3.5. That would be the midpoint. Okay, let's consider this example here. So it says to find the lengths of each side of the triangle, then find the perimeter of the triangle. All right, so the way it wants you to do this, though, is not with the distance formula, but with the Pythagorean theorem. So in order to do that, you would need to make 3 mini right triangles for each 3 lengths. So let's do AB first. So for AB, we would draw its horizontal component and its vertical component. I'm actually going to use a straight edge here. Okay, so the horizontal component has a length of 1. Vertical component has a length of 1, 2, 3, 4, 5, 6, 7. So for segment AB, you would do a squared plus b squared equals c squared. So 1 squared plus 7 squared equals c is just ab squared. And then simplify. 1 squared plus 7 squared, which is 49, is 50. And then you would take the square root of each side. Okay, now the square root of 50, let's find an exact answer. So the square root of 50, can you think of the largest factor of 50 that is a perfect square? So it would be 25 and 2. So you can rewrite this as the square root of 25 times the square root of 2, or 25, the square root of 25 is 5. So this would be 5 times the square root of 2 equals AB. Okay, now let's do the same thing for segment BC. So for BC, let's draw in the components. So the X component from B to C and the Y component from B to C. So the X component has a length of 1, 2, 3, 4, 5, 6, and the Y component has a length of 2. So for BC, you would do 6 squared plus 2 squared equals BC squared. Simplify this. 36 plus 4 would be 40. And then the largest factor of 40 that's a perfect square, I'm thinking is going to be 4. So 4 and 10. So the square root of 4 times the square root of 10. When you take the square root of both sides, the square root of 4 becomes 2. The square root of 10 is not a perfect square, so it stays under the radical. 2 square root of 10 equals BC. Okay, so now what I'm going to have you do is find CA as an exit ticket, find the length of CA using this method, and then find the perimeter. For the perimeter, you're just going to do to the nearest hundredth. Okay, because we adding these kind of numbers with different numbers under the square root is a whole nother lesson. Okay, so we'll stop there.